Linux operating system. We look at a little bit of the history of Linux operating systems before we start writing commands and getting to AWS and all that. I wanted to have a little background. These slides are self-explanatory. I'm not going to go deep into it. After the class, I'm going to post it so you can read it for yourself if you have time. But I just want to highlight some key things that you need to know. So the world of operating system, most operating system can be grouped into families. One, you have the Microsoft NT descendants, which has Windows, Xbox OS, Windows phones, and all that. So that's the descendants from Microsoft NT, how it started. So pretty much everything else has a lineage going back to Unix. So everything apart from Microsoft is Unix, like Mac OS, X, Linux, Android, Chrome operating system, and even the PS4 operating systems, right? All use Unix systems, right? So these are the two key operating systems that you have, Microsoft and Unix. And so every other thing like the Linux operating system that we're going to learn about all comes from Linux, from Unix. If you care about schematics and how the development starts, if you're interested or curious to know, this is an eye chart. You can just go through it and all the versioning, how it develops and all that. So if you're interested in this, I'll post this so you can take a look at it. It's interesting to know how all these operating systems started, right? And so they have a good schematic here and they have the years, how it started here. It's not going to come in your interview or anything. It's just if you're curious to know. There are some people that are really curious to know. So what is Unix? Unix was an operating system developed by Bell Labs in the mid-1960s. Many of the innovations and design choices, the original Unix team have lived up to 50 plus years later, including the idea of multi-user operating systems. That's how you using a hierarchical file system that still exists in the present Linux operating system. So Unix is the grandfather of all modern operating systems. It started with Unix. It came with a philosophy. So in the early days of computers, operating systems were tightly tied to specific hardware. So what Unix did was decouple the software, right, and make it more portable. So the philosophy emphasizes modular software, right? Instead of creating a whole giant big application, you can segregate them, right? You put them in modules, modular software. So you see most of the programming language start using modular programming systems. They create things in modules. So you write programs that do not do one thing and do it well. Write programs to work together. Write programs to handle text streams because it is a universal interface. So I have another schematics here for you to also read through real quick. I just want to highlight some few things. So today, the name Unix is the trademark of a global consortium called Open Group. So Open, it's a open software. Let's call it. It's open that most people can go in within the group. If you want to belong to the group, you can belong to the Unix group and go in and improve the software. Most software organizations belong to it. They go in and make changes as they want, create new features, and use the software. So you also have Unix-like application or operating systems as well. The free software movement this is how the open source software came about. It's just a story of the free software, that you have software for free. It started by a guy called Richard Stallman. Yeah, he wanted the freedom of software. So he started a philosophy, donating applications or operating systems for everybody to have it for free. And everybody can go in and make changes to it and so on and so forth. And there's a project called GNU project. So that's how he started. Richard Stallman was the leader of that project, and he started that. So let's take a look into the Linux kernel, right? This is important. So a guy by the name of Linus Torvalds was working on creating his own kernel known as Linux. The kernel is part of an operating system that facilitates interaction between hardware and software. This is how Linux came about. But it started originally from Unix, it all from Unix. So at the time, many GNU PCs were complete, but it lacked the kernel. This is the kernel. This is the heart of the application. So Linus Torvald combined his kernel with the existing GNU components to create a full operating system. So what he did was he took the pieces from Unix that was created, right, and added his own kernel. So you have applications that goes in between. You have application, you have kernel that goes between your CPUs, your memory and devices, and that became the Linux kernel, right? So the name, when you hear the name Linux, it comes from a man by the name of Linus Torvalds. So that's how Linux came about. That's the history of. So this is exactly how the kernel looks like. Applications have application here. Then you have the shell. The shell is the interface between the application and the kernel. So a kernel is a computer program that forms the core of an operating system and manages critical tasks like memory management, task scheduling, managing hardware. So while a kernel is a critical piece, it is not the same as operating system. Kernel is just a part of, right? An engine is an essential core of a car, but you cannot drive an engine. You drive a car. So you cannot say a kernel is the operating system. It's the core of the operating system. It's not the operating system. But most people think kernel is the operating system. No, it's not the operating system. We have other things that are going around along the operating system itself. So today the term Linux refers to both the kernel created by Linus Torvalds and all the software that is part of the Linux ecosystem. So some users feel strongly that the name GNU/Linux should be used instead of to reflect. So now you only hear about Linux. You don't hear about GNU projects. But what innovation, when you talk about innovation, you take whatever technology exists right now and you develop your own, or you can combine a combination of technologies and it becomes your own, right? So that's exactly what the people that started the original innovation or created those other things will not be recognized. Is someone that takes those things and combine them together is the person that's recognized. That's what happened to Linux. So now everybody knows about Linux. Nobody really knows about GNU projects. This is another story. You can read this on your own. So we have Linux distribution. So the Linux kernel itself is not a full-fledged operating system. When people talk about Linux-based operating system, they are referring to Linux distributions. So typically, Linux distribution bundles together the Linux kernel, GNU tools, documentation, a package manager, a Windows system, and desktop environments. So there are nearly 1,000 Linux distribution. They call it distros. So if I use the word distros, know that I'm talking about Linux distribution. So about 1,000 of them are available. Some are more popular ones, including like you will hear about Fedora, you hear about Ubuntu, Debian, and Slackware. You will use Ubuntu a lot in this class, so you hear a lot about Ubuntu, Red Hat, and all that. Okay, so this is another schematics. If you're interested, it gives you system 3 and V family. If you want the genealogy of it, so this is it. It even has Darwin in here, so you can read that. Okay, shell. You have application, you have the shell, then you have the kernel, right? So a shell is a computer interface to an operating system. So it's an interface so you write an application. Your application stays here, you have a shell. A shell has to interpret whatever you're writing to the kernel, right? So shell exposes the operating system services to human users or other programs, right? So whatever you're writing, whatever you're doing, you're talking to the shell and the shell. So when you start writing code, you're writing to a shell, and the shell is the thing that would interpret that to the kernel. So the shell takes our command and give them to the operating system to perform. It's named a shell because it's the outer layer around the operating system, like the shell around an oyster. So it looks like an oyster, right? So in those days when computer came out, you used to have terminals, right? Now we don't use terminals anymore. We're using software as a terminal. So you download in this class, if you're using Windows operating system, you download what's called Mobile Extern, and that will be your terminal. If you're using a Mac operating system, Mac computers come with terminal itself. You don't need to download anything. You can still use terminal in Mac operating system. But you can see that the terminal, downloadable or directly with the system, has to go through a shell. In this case, it's a bash shell in Linux, or what we call born again shell, right? And before then it gets into the kernel. So a shell has to stay in between to do the interpretation to the operating system. Okay, so we write a command like this, a touch command. It goes through a shell. This is the bash shell. This is the CS shell. So you have the fish shell. So we'll talk more about the bash shell in this class. That's what we use. So again, the kernel, we'll talk about the kernel. The kernel is a computer program that forms the core of the operating. We already looked at this slide. I think I repeated it again. So this is the bash shell. On most Linux-based systems, the default shell program is bash, right? There are many other shells, but bash is currently the most popular. The name bash is an acronym for Born Again Shell, a punny reference to Stephen Bourne, the creator of Bash's direct ancestor. So bash came from Stephen Bourne, right? We have Born Again Shell, is the one that created the bash. Okay, I think that ends a history on Linux, okay? So I'll post this so you can read about this. It's a little bit interesting, but you can read all about this. But so let's switch gear real quick. We're going to learn about Linux and Linux commands. So there are a few things that I need you guys to do. One is to download an application called Mobile Extern. Mobile Extern. If you want to do it now, it's fine with me, totally fine with me. Let me see if I can get to the website and show you how to do it. I think I have it there. I'll post this slide so you can go in here and you can click the link and do it. If you want to do it while we're doing it right now, and I can send you the link on this chart. Let me see if I can have a chart. If you have your laptop on and running, you can go ahead and download it right now. So what you do is when you get to that link, when you use the link, just go to download, right? Then you can install the portable edition. Or you can, any of the edition will work very well. You can install the portable edition. Just click on portable edition, right? And it's going to download it. And you click open file once it's downloaded. And that will be downloaded to, right now you can open it up right here. You can extract the application or run the application. Let's run it. So application is run, so it will give you this interface. I already have one already, so it's going to look like this. Right. So it's going to look like this by the time. So this is the interface that we'll use. This will be a terminal. This will be a SSH client. Also call it SSH client. That's how you use to connect to your cloud infrastructures. If you have a Mac operating system, if you go to your Mac, there's what they call terminal. Terminal is the same thing as this. If you're not comfortable using terminal on Mac, you can download Mobile Extern as well. So this is what we're going to be using throughout this class. Okay. So that's one assignment for you to do. Download your mobile XTEM. I'll recommend that you download it today because the next class will start. As a matter of fact, we'll start running commands today as well. I'll show you a few commands that you can run. So another thing that we're going to do is, let me see. So you have mobile XTEM. You can also use POTI. There's another one called POTI that you can use as SSH client. We have file FTP tools. I use FileZilla. This is the one that you use to transfer files from one directory to the other. But don't worry about it for now. We'll get into that. The main thing that I need you to download right now is mobile XTEM. For us to get into this Linux, before I even start, let me introduce you to AWS.